So let's discuss this question related to radioactivity. Alright, now this one. We have U-238 half-life is given like this for years. And then the sample of uranium-238 contains 5.43 times 10 to the power of 14th atoms. We have to calculate the rate of decay in Curie and Becquerel. Alright, let's do it. The very basic thing is to do the listing. So T half is 4.468 times 10 to the 9 years, and we have to change it to per second, and that would be for 365 days times 24 hours times 3,600 seconds. That would be 1.409 times 10 to the 17th second. It also mentioned in the question that the samples of uranium contains 5.43 times 10 to the power 14 atoms, and that this would be our nuclei, the initial nuclei. Alright, question A, disuruh cari rate of decay. That would be dN over dt. So disuruh kita cari in Curie and Becquerel. In the previous video, I have explained to you the equation for dN over dt, and that will be negative lambda n. But the problem, we don't have the lambda, which is the constant decay. But we can get that by using lambda. There's another equation, which is lambda equals to ln 2 over t half. Okay, we're going to use this one. And since we do have the t half, that will be this much. Okay, jom kita masukkan. And we can get 4.92 times 10 to the negative 18 per second. So don't forget, this is the unit for decay constant per second. We are going to put it back into this equation and the nuclei like that. And our final answer is 2.67 times 10 to the negative 31 Curie. We have done in Curie. Now let's go to Becquerel. Alright, since 1 Curie equals to 3.7 times 10 to the 10th Becquerel, kita kenalah kalikan dengan 3.7 kali 10 kuasa 10. So, kita akan dapat 9.8827 kali 10 kuasa 21 Becquerel. We are done with question A. Now, let's go to question B. Dia kata, what is the fraction of nuclei left after 8 days? So, bila dia kata fraction of nuclei, actually, dia minta kita yang ini N over N naught. Kalau ingat lagi dalam video sebelum ni, we have N sama dengan N naught exponent negative lambda T. Do you remember this one? So, we're going to put the N naught to the other side. So, our N per N naught equals to exponent negative lambda T. Kan tadi dia cakap after 8 days, so we have to change 8 days into second by putting times 10 to 20 times 24 hours times 3,600 second, and that would be 691,200 second. The decay constant from the previous question, we got 4.92. And then kita masukkanlah dekat dalam ni. Saya dah tak muat ruang pula. And then you can get your answer as 1. Give it a try and you can get your 1. And lastly, question C. It asks us to sketch the decay curve. We have to put in all the information. I'm going to put this one in years because it's much easier. Okay, we're going to start with our N naught. That is 4.53 times 10 to the power 14th. Half of the N naught, we have to do the calculation ourselves lah. 5.43 kali 10 kuasa 14 tu, korang bahagilah dengan 2. So that would be 2.72 times 10 to the power 14th. Okay, and then you start lah buat the exponential curve like this. This would be the first half life. Oh, pucut. And that would be 4.468 times 10 to the power 9th years. And then you boleh continue. I think it's sufficient enough lah kalau you buat sampai sini saja cukup. That's it. Thank you everyone.